Okay, there we go. So next thing we have is this worksheet 2.8. We're going to begin this in class, and then we're going to have you finish it at home. Now, when you look at this worksheet here, this one is way more complicated than what you're going to have to be able to do on the test. So what we're going to do is simplify this a little bit, because like I told you on the test, your proofs are going to be fill in the blank. And on these, we didn't really give you a whole lot of fill in the blank on here. So we're going to change this up a little bit so it makes it a little bit easier to do. And we're going to fill in some of these, and then we'll have you guys fill in the reasons. So let's start with this first one here. We're going to fill in all these statements. So I'm going to have you copy these first, and then we'll go ahead and do the proof. Anybody still copying those down? All right, let's go ahead and start it off. First step, like we said always, first step is almost always going to be the given. If you look at step one, it does match up with your given. So there, I'm going to put step one is given. And then step one had two different parts to it, and it's going to fill in both steps 2 and 3 for us. So the first thing we're going to do is take this first part of our given. It says that angles 1 and 2 form a linear pair. If you look in your picture, angles 1 and 2 form a straight line. That makes them a linear pair. If they're a linear pair, then that means they add up to 180. And if you remember, that is our supplement theorem, the one we talked about in section 8. Supplement theorem says if they form a linear pair, then they add up to 180. And then the other part of our given, that first step, said that 2 and 3 were supplementary to each other. Now, when they give you a vocabulary word in your given, typically that's going to show up in your proof by using the definition of that word. Since 2 and 3 are supplementary, we need to know what that means. Supplementary means they add up to 180, which is what we did here in step 3. Since 2 and 3 were supplementary, that meant they added up to 180. So here we're going to use the definition of supplementary. Then to step 4. Step 4 is going to look a lot like we did in our vertical angles theorem back in your notes. In steps 2 and 3, we have two things equal to 180. Angle 1 plus angle 2 equals 180, and angle 2 plus angle 3 equals 180. Since they're both equal to 180, what we can do is take, I'm just going to take the second one, angle 2 plus angle 3, and we can slide it in for that 180 up here. Since angle 2 plus angle 3 equals 180, we can put it in for 180. When you do that, you get angle 1 plus angle 2 on the left, angle 2 plus angle 3 on the right. Our reason for that is substitution. substituted one in for the other. And again, sometimes we'll put property behind there. If you just write the substitution, I'll know what you're talking about. Now, from step 4 to step 5, I think you guys can come up with this one. Step 4, we have angle 1 plus angle 2 equals angle 2 plus angle 3. In step 5, it's just down to angle 1 equals angle 3. So in other words, in step 4, we got rid of the measure of angle 2 on both sides. What allows us to get rid of the measure of angle 2 on both sides of our equation? Or what did we do to get rid of it? We did subtraction, yeah. We subtracted angle 2 from both sides. Step 5 would be the subtraction property. And then again, like the vertical angles theorem, step 5 to step 6, we go from angle 1 equaling angle 3 to angle 1 being congruent to angle 3. Anybody remember what allows us to switch between equals and congruent? Or it could be vice versa. You could go from congruent to equal. That one's the definition of congruence. And if you want on that, you can use your congruent symbol. You don't have to write it all out. All right, there's our first proof. Now, the second proof is one you're going to do on your own at home, but I'm going to fill in some of these missing parts. So we're going to fill in missing parts on 2, 3, and 4. So go ahead and do this, and then we'll move on to one that we're going to do together. Anybody need more time to copy that? All right, third one is another one we're going to have you do yourself. But again, I'm going to fill in some of these parts here for you. All right, on this one, leave that blank down here. Step 2, this is going to be definition of a right angle. And on step 3, we're going to have 2 parts to step 3. The measure of angle 1 plus the measure of angle 2 equals the measure of angle ABE. And the measure of angle 2 plus the measure of angle 3 is equal to the measure of angle BBC. And then step 4 is going to be almost the exact same thing. We're going to take these two and change them to 90s. So the measure of angle 1 plus the measure of angle 2 is going to equal 90. The measure of angle 2 plus the measure of angle 3 is going to equal 90. Steps 5 and 6, we're going to give you the reasons. Step 5's reason is going to be substitution property. Step 6 is going to be subtraction property. That will fill in that third one for us. And like I said, you'll go ahead and on your own later on, you're going to fill in those missing parts there. Let's go down to the fourth one. This one we are going to do together. On this fourth one, we're going to fill in all the statements. So step 2, angle ABC is a right angle. Step 3, we're going to have the measure of angle ABC equals 90. And then in step 4, the measure of angle 1 plus the measure of angle 2 equals the measure of angle ABC. Step 5 will be the measure of angle 1 plus the measure of angle 2 equals 90. Step 6, we have the measure of angle 1 plus the measure of angle 3 equals 90. Step 7, we got the measure of angle 1 plus the measure of angle 2 on the left. And then on the right, we're going to have the measure of angle 1 plus the measure of angle 3. And then the last one will give you the measure of angle 2 equals the measure of angle 3. And then again, on this one, we are going to fill in all of the reasons. All right, take a look at those. I think you guys can get a couple of these. We'll start with the first one. Step 1, what's the reason for step 1? That one is given to us. If you look at the given, it matches up with step 1. There's our first step. First step's given. In step 2, it says that angle ABC is a right angle. Now here's where that's coming from. In your first step, we said that AB and BC were perpendicular. If you go to your picture, AB and BC are perpendicular. That means they're going to form a right angle where they meet. So here's AB, here's BC. They're going to form a right angle. I'm just going to put a little box in there to show that. They're going to be forming a right angle. Now, our reason for that goes back to our definition of perpendicular. When we define perpendicular lines, we said that they form a right angle where they intersect. And then from step 2 to step 3, if it forms a right angle, then we know that that right angle is 90 degrees. So anytime you have a right angle, it's going to be 90 degrees. That's from the definition of a right angle. Step 4. Step 4 says angle 1 plus angle 2 equals angle ABC. Now that's not coming from things before in the proof. That's actually coming from your picture. If you come up here to the picture, angles 1 and 2, when you put them together, give you angle ABC. And that's one of our theorems we talked about in the notes. Angle addition, or actually it's postulate, angle addition postulate. You add the two little angles together, they will give you the big angle. That's what's happening in step 4. That's angle addition postulate. And now we go to step 5. Step 5, from step 4 to step 5, the only thing that changed is on the right-hand side. The measure of angle ABC became 90. Now the reason we can do that is because of step 3. In step 3, we said angle ABC equals 90. Since those two are equal to each other, what we can do is take that 90 and put it in for angle ABC. That is just substitution right there. You're taking one thing out and putting something in for it. Now, step 6, this one, you're probably not going to see this one right away. Angle 1 plus angle 3 equals 90. This goes back to the given. Back here in the given, we said angles 1 and 3 are complementary. If they're complementary, our definition of complementary says that they're going to add up to 90. Since they are complementary in the given, that means they're going to add up to complementary down here, or they're going to add up to 90 down here in step 6. This is the definition of complementary. And now step 7, we take the previous 2 steps and put them together. Angle 1 plus angle 2 equals 90, and angle 1 plus angle 3 equals 90. Since both of these things on the left are equal to 90, we can put the things on the left equal to each other. So angle 1 plus angle 2 will equal angle 1 plus angle 3. That right there is substitution. Again, we're taking one thing out, putting something else in for it. Step 8, I think you guys can come up with this one. In step 7, we have angle 1 plus angle 2 equals angle 1 plus angle 3. Step 8, the angle 1s on each side disappear. What did we do to step 7 to get to step 8? We got rid of the angle 1 on each side. What did we do to get rid of the angle 1 on each side? That one, that's subtraction. We subtracted angle 1 from both sides. That leaves us with angle 2 on the left. Leaves us with angle 3 on the right. Subtraction property lets you subtract the same thing from both sides of the equation. And then again, in step 8 to step 9, same step as we had on our last proof, we're going to go from equal to congruent. Anytime we flip from congruence to equals, that's the definition of congruence. The only thing that changed in there was the equal sign became congruent. All right, there's our 4th one. 2 proofs left on this one. And the 5th one here is one we're going to have to do on your own, but once again, we're going to fill in some of these things to make it a little easier for you. Let's just do the statements again. We're going to put angle ABC. Here's a right angle. For step 3, angle ABC is 90. Step 4, we're going to have angle 1 plus angle 2 equals angle ABC. And then for step 5, angle 1 plus angle 2 is going to equal 90. And that one we'll have you finish off on your own. You're just going to fill in the missing reasons over here on the right. Everybody still copying that? All right, last one, sixth proof here. Once again, we're going to fill in the statements. We're going to give you the statements here, and we'll fill in the reasons. So on number 2, angle 5 is going to equal angle 6. Step 3, angle 4 and angle 5 are going to be a linear pair. Step 4, we're going to have the measure of angle 4 plus the measure of angle 5 equal 180. And then in step 6, we're going to change one thing. We're going to change the measure of angle 5 to the measure of angle 6. And then we're going to come up with all the reasons. All right, anybody still copying? Okay, let's finish this one off. First step, angle 5 is congruent to angle 6. Where does that come from? That is given. And like I've said, almost every single time, your first step is going to be given. Now, step 1 to step 2, we've done this a few times now. Step 1, we're going from congruent to step 2 being equal. Pretty much everything else stayed the same. We go from congruent to equal. What do we call that? Have we done it enough to remember this one? Switch from congruent to equal or from equal to congruent. What do we call that? Remember that? Yeah, that's the definition of congruence. Anytime we flip back and forth between congruent and equals, that's the definition of congruence. And you'll see that a lot. So that's one you want to remember. Now, step 3 kind of comes out of nowhere. It says angles 4 and 5 are a linear pair. If you go up to your picture, here's where that's coming from. 4 and 5 form a straight line. That makes them a linear pair. And that comes from the definition of a linear pair. If they form a straight line, if you have two adjacent angles form a straight line, they're a linear pair. So step 3 is definition of a linear pair. And then we go back to one that came from the notes here. If angles 4 and 5 are a linear pair, then we know that they add up to 180. Once again, if you use your picture, 4 and 5 are forming a straight line. That means they add up to 180. That comes right from our notes today, the supplement theorem. Supplement theorem says if they are a linear pair, then they're going to add up to 180. So we had them as a linear pair here. Now in step 4, we have them add up to 180. And then step 4 to step 5. The only thing that changes from step 4 to step 5 is the angle 5 becomes an angle 6. And here's where that's coming from. Back here in step 2, we said that angle 5 is equal to angle 6. So what I can do is take that angle 6, and I can bring it down here and put it in for angle 5. When I do that, the angle 4 stays the same on the left. The angle 5 becomes angle 6. The 180 stays 180 on the right. All we did is take out one thing, put another in for it. Anybody remember what that's called? When you take one out, put another in for it? Substitution is what we're looking for here again. Substitution allows you to take one out, put the other in for it. And then from step 5 to step 6, since 4 and 6 add up to 180, that means they're going to be supplementary to each other. If you go back to our definition of supplementary, if two things add up to 180, that means they're supplementary. This is the definition of supplementary. Okay, Now, that's as much as we're going to do together. The rest of this, we're going to have you work at on your own, filling in those other 3. And that's one of the things you can do at home on your next block day at home. Also, we want you to do that chapter 2 study guide while you're at home. And then when you come in next time, we're going to go through that chapter 2 study guide because we're going to take your test the next time you guys come to class. All right, any questions over here? Okay, the rest of the time is yours to work.